Question 7, part E, in which they are showing us that the sun also rotates about its axis of rotation just like the earth do. Okay. So this is its axis of rotation imaginary which is passing from its center about which it rotates. Okay. Now dear students, important to know that the when we measure the wavelength of hydrogen, okay, by drawing its spectrum, the hydrogen spectrum in laboratory, okay, and you know how do we make a spectrum? There are two kinds of spectrum, absorption and emission spectrum. Okay, anyways, from the hydrogen spectrum, when we measure the wavelength, its wavelength is 656.2797. Look at this, 97 nanometer. Okay, but what we observe, since it is rotating, okay, so the wavelength, if I show you that, imagine it is just for understanding, right? Imagine this is a light that is reaching the earth. Okay. So dear students, this is question basically about the Doppler effect, and we can say this is a source, right? And this is an observer, right? Now, so the light is coming from the point P. Since the sun is rotating about its axis, so I just want to show you the new position of this point P. So they also show us the clockwise rotation. So just imagine now that particle is, we can draw at this point. Okay, the point P. Okay. So when, don't you think, because the radius of the sun is so large that you can't ignore it. Okay, and this is 700,000 kilometers. Okay, so don't you think now this point P is relatively closer to the sun, closer to the earth? So which means that the light now that will reach on the earth means towards the observer will perceive it as a frequency shift and the wavelength shift. Okay, and obviously the wavelength of the light for the earth would be like this for the earth. Okay, because I'm saying it is a apparent change, understand, because that is all about the Doppler effect. Doppler effect is always about a apparent change in frequency due to relative motion. Okay, so now don't you think that there, and that what we observe. Okay, so this is a actual wavelength of the light from the hydrogen spectrum, but when the wavelength that is emitted from the P, you see that this is less than the wavelength of the hydrogen light, which means that there is a wavelength shift. Okay, from a longer wave to the shorter wave, and in the Doppler effect topic we call it blue shift, which means that the source is moving towards the observer, and this decrease in a wavelength is a clear sign that the point P is approaching, okay, towards earth.